So now in this video, we're going to look at the P-channel enhancement mode MOSFET. The one that I got is the BS250. Now I did not get one in the TO92 package. I ordered it from DigiKey, and I don't know if it's the cheapest or what, or the only kind they had, but I got it in the E-line package. So it's flat on the back, it actually has a dimple in the middle, and it's smaller on the front, also flat right there. And it says the part number and maybe some other stuff. But in any case, left pin is drain, middle pin is gate, and right pin is source with the E-line package. If you had the TO92, maybe the source and the drain are swapped. I don't know. Make sure you check for the component you got. So there is no universal symbol. So based on a couple other sources, this is my favorite symbol for the P-channel enhancement mode MOSFET. So that's what I'm going to use, even though other people use different symbols and will not like that I use this. So we have the source to the positive supply. That is the right pin. So the narrow part of the component there is up to the positive supply. Middle pin is the gate. We got that over there. And then down here, the drain is to the load. So when it comes to these MOSFETs, the load is on the drain side, whether it goes towards the positive supply or the negative supply. So here we have a high side switch. We're closer to the positive supply. You know, much like a PNP, bipolar junction transistor. P-channel enhancement mode MOSFET works very, very similar, except we don't really depend on current when it comes to the drain. So right now that does say off. Looking through the camera, it looks like on. But yeah, positive supply is off. So with the N channel, that turned it on when we put the gate to the positive supply. And now we're going to turn it on, go to the negative supply, and there you can see the LED is on. So we'll quickly explain it again for the P channel, because I covered this with the N channel video. So this is P channel enhancement. So we got the channel, and it needs to be made more positive. What that means is you need to push electrons out of it. And the gate and channel are like a capacitor. There's an insulative material in between them, and that means that one side can build up a positive charge and the other, much like a capacitor. Very, very weak capacitor though. Barely stores any charge. You can quickly charge it or discharge it, even if you have a pretty high value resistor. You know, so that might help protect the component if you have a resistor. And other things, you know, you don't always want to be able to short to a supply voltage at the gate. Plus you might want to use a resistor to hold up the voltage at all times while you flip back and forth, or a resistor that helps hold it down while you're flipping back and forth. So not showing that there, but just want to mention that. So in any case, we had the jumper to the positive supply. That kept it off. Now we're at the negative supply. Now it's on. So we make the gate more negative. And again, the channel will be the opposite. Gate fills up with electrons. Channel loses electrons. You know, making it more positively charged is one way to think of it. But in any case, that's when it conducts better, because it's a P-channel enhancement right there. And you go to the positive supply, then it will be off. And right there, it stayed on. I didn't know if it would stay on or off. And this one's doing better than the N channel. I filmed it, but I deleted that scenery. But when you let go, it may be either on or off. And it was staying on once in a while before. There we go. So just be aware of that. Since it's P channel, that will turn it on. And this will turn it off. So positive supply makes the gate more positive, channel more negative, more electrons, and thus it doesn't conduct. But you make the gate more negative, channel more positive. P-channel enhancement right there. That's what that means. So I mostly see these as switches. That's all I can think of them being used in the circuits I've seen for the most part. I'm sure there's creative uses for them where they do other stuff. But that's generally how I see them, switches. So that's really all I show, you know. That's all I remember showing, unless I come across a schematic where I was able to do more with it. But that's generally what I see. So in any case, that's it for this video. Thanks for watching. Make sure you check out one of the other videos I posted on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.